Robots have become an invaluable part of modern production processes. But just like humans, robots are not infallible. There is always the danger of the smallest error going unnoticed and a vast quantity of defective products being turned out. And there is nothing worse than such products leaving the factory. This makes constant checking more important than ever.
Yes, I know why we're getting so many complaints. Somebody must be using the bad parts that should have been thrown out. We're not...
In this process, robots are used to insert bearings. First, the bearing is put in place. Next, it is inserted under great pressure and then checked. The important point here is that the jigs are not worn in any way. To ensure daily checking before the robots start work, Q-Compo labels like these are conspicuously located on the places that must be checked because they are likely to be worn down. This is an example of the kind of visual control that is particularly important with automatic processes to avoid defective products. In this section, a meeting is held every morning to check any defective products from the previous day's output. The product in question is carefully examined to discover what went wrong.
We used to find that although some of the operators were quick to understand why defects occurred, others weren't. But now we hold these meetings, which we call the morning market. We all get together, have a close look at the faulty part, decide what the problem is, and then have a discussion about what should be done to prevent the same kind of thing happening again. It gets everyone more involved and also serves as a valuable form of training as well.
The examination of defective products is used here as a basis for control improvements in the constant effort to produce zero defects. These are storage shells specially designed for cutting tools of various types as part of an effort to improve quality control. Let's see how they're organized. The tools are kept ready for use in individual trays to avoid confusion. Soft storage is used to avoid damage to the cutting edges. A reasonable number of each type is kept, depending on frequency of use. The red trays are where tips and drills are returned after use. The yellow trays are for parts less frequently used. The black line in the drill trays marks the point to which each drill can be used.
Our storage system was really rough before we introduced the new individual trays. All the tools were piled up together, which was dangerous and inefficient. Now we can find tools easily and control quality better.
This is an excellent example of the relationship between visual control and quality control. The person in charge simply checks the shelves once a day and can see immediately which tools are damaged or missing and how many need repairing or replacing. Let's now take a look at a paint line that uses air jets. If the pressure drops for any reason, it can interfere with the spraying process and also lead to defective products. To avoid pressure problems, they use flashing lamps and an alarm speaker to indicate when the pressure drops below a fixed limit. This is a good example of visual control to avoid the possibility of producing inferior products. As our final example, here are storage shelves for small parts. You can see that there are many interesting symbols on the labels. This is the idea used in this factory to find necessary parts quickly and without mistakes.
The reference numbers for parts we used to use could have as many as 12 numerals, so it was very easy to pick up the wrong parts. Somebody came up with the idea of using combinations of basic coloured symbols next to the numbers. If they match, you've got the right part. It's very easy, really avoids mistakes, and is also much more interesting than struggling with long numbers.
This is a perfect example of how to avoid clumsy systems and unnecessary mistakes, and is the kind of idea that can be used in any situation where confusion is likely. Now let's review the 3 main points for improving visual control of quality. Point 1. Avoid the chance of defects resulting from human error. For example, make sure that there can be no confusion between perfect products and defective ones. Avoid mixing very similar but different products. Differentiate using colours, patterns and marks. Ask workers brought in to help from other departments to wear a distinguishing mark, such as different coloured hats, so that they can be spotted easily and given appropriate instructions. Point 2. Clearly identify potential function or performance abnormality points by using Q-compo labels to avoid checking misses and flashing lights and alarms to indicate abnormalities of temperature, speed or pressure. Point 3. Implement proper checking procedures. Use double-checking, morning markets and reminders to maintain everyone's awareness. Also regularly check measuring instruments. The use of more automation might appear to guarantee better quality control. But we hope we have demonstrated the vital importance of vigilance on the shop floor to ensure that there is guaranteed quality at every stage in the production process. Visual control improvements can really help with this and help make zero defects a reality. In the final part, we will take a look at safety control systems. Green, yellow, red. Go, caution, stop. 3 simple colours that transmit their message clearly and effectively. As we pointed out at the beginning of these videos, road signs are a perfect example of visual controls in daily life. They have been developed and improved over many years, using a huge variety of colours and patterns. Their prime purpose is to increase safety on the road. And if we think carefully about them, we should be able to find lots of ideas applicable to shop floor safety as well. And that's what we'd like to do in this final part.
Ouch! Hit that door again. Oh, I wish they'd do something about it. Hey, you should watch where you're going.
What do you mean, me? You're the one who needs glasses.
What?
Oh no! Help! Help! Help!
It's very easy for anyone to forget or ignore the basic rules of working, or get illusions that things are safe when in fact they are not. That's how accidents happen. The purpose of visual control is to increase awareness and so cover for human weaknesses. One, 29, 300. What do you think these figures refer to? Well, this is a ratio known as Heinrich's rule. It means that for every case of someone being seriously injured in an accident, there are 29 cases of minor injuries and 300 other incidences where an accident is narrowly avoided. Now, if you can avoid the close calls and near misses, you have no injuries of any kind to worry about. In other words, the only way to avoid injuries is to do away with dangerous situations. Visual control is designed to do just that by pointing out potential dangers. Let's begin with the simplest of safety ideas, but a very effective one. Although this looks just like an ordinary door, in fact a clever safety control has been implemented. Look at the floor. The marks show exactly where and in which direction the door opens. In other words, the danger zone is delineated. And also the window is changed from opaque to clear glass, so that you can always see who's coming from the other side and avoid collisions. The next example is a very common danger point, a grinder which is used by many people every day. The problem is it revolving or not? It's impossible to tell just by looking. Let's try it. Yes, it was in fact switched on. The potential danger here is obvious. One solution is to attach a lamp which flashes when the grinder is turning. The other point about this grinder is that momentum keeps the wheel turning even when the machine is switched off. So the lamp continues flashing as long as the grinder is moving, whether the machine is switched on or not. This next safety control has been given the amusing name of the magic broomstick. It is in fact an automatic rail sweeping device. And it's designed to stop if anyone approaches, using a magic eye. This shop floor uses many other visual controls. Lamps on the vehicles, clear warning signs at crossing points, foot marks at stopping points, and so on. Being prepared for emergencies is another aspect of safety control. A safety board like this can be used to point out correct procedures, necessary telephone numbers, etc. Not only does this remind everyone of potential dangers, it also serves as a point of immediate reference when something dangerous occurs. Let's listen to what the chief foreman of this section has to say about it.
Our heat processing system is in operation 24 hours a day, and it's obviously vital that there is an immediate response if anything goes wrong. We decided one improvement we could make was to have a board like this to make emergency procedures clear to everyone. Another safety feature we set up is a hotline between the production line and the control room.
Finally, let's take a look at the safety features incorporated in a huge warehouse for small parts, which uses an elevator system. The parking places for carts are clearly marked to avoid disturbances. The entrance to the storage area is marked in yellow with red staff-only notices. A chain is used for safety control whenever items are brought in or taken out. When the pin attached to the chain is removed, the elevator automatically stops. The safety bar at the other side also stops the elevator if lifted. The power supply is cut off until both the chain and the bar are properly positioned. The result of these features is to make this a trouble-free work area, where safety really does come first. Let's review the 4 main points for improving visual control of safety. Point 1. Get people's attention by using strong patterns and fluorescent colors to indicate steps, protuberances, and height problems. Point 2. Clearly mark crossing points both on the shop floor and at outdoor sites by using curve mirrors, stop marks, and other signs. Point 3. Take care of the handling and storage of dangerous materials. Apply limits stricter than the actual law, and use prominent skull and crossbones marks. Point 4. Make emergency buttons large, obvious, and accessible, so that they can be used immediately when necessary. Safety control has to be a priority in any working situation every minute of the day and night. And we hope we have given you some useful ideas for visual control systems to avoid accidents and unnecessary problems. All the real examples we have shown in these 3 videos were the result of people getting together to think carefully about ways to apply the principles of the 5S system to their own particular problem situations. We hope you too can develop your own ideas to make your workplace safer, more efficient, and generally a more pleasant place to work.